A very good day. My name is Dineshwaran, unlike you, Gunasekharan, and my matrix ID is MA19091. So now I would like to start the online presentation for our E2/2 experiment flow over immersed body. So I would like to start the introduction. So flow around immersed bodies. So flow around immersed bodies is when a solid body is completely immersed into the path of a flowing fluid and the body is simultaneously subjected to force or pressure. So when we take a solid body and subject it to the path of a flowing fluid, the body is subjected to force or pressure which causes lift or drag force. So this is basically the idea of our experiment, and we have studied revolving this idea. So when fluid flows past an object or the way around, an interaction between the object and fluid occurs. So the interaction creates a layer that sticks on the object's surface due to the viscosity of the fluid. So this layer is known as the boundary layer, and the boundary layer is taken into subject and consideration for this experiment, and our study also revolves around the boundary layer concept. So who discovered it? So Ludwig Prandtl rendered the first description of the boundary layer concept in his paper. He theorized that an effect of friction was to cause the fluid immediately adjacent to the surface to stick on the surface. This concept was brought in by Ludwig Prandtl. So Ludwig Prandtl depicted this idea and rendered it to the society for over 200 years, and he started and initiated the mold. So our objective of these experiments is to study the effects of boundary layer and fluid flow when the plate is fully immersed in a flowing fluid. Second is to calculate the velocity distribution for a cylinder shaped plate in a fully immersed flowing fluid. And third is to configure a complete estimation method for fluid flow and measure the drag force. So these three was our main objective, and we are proud to say that we have derived this outcome, and we have rendered it in our results, discussion, and also conclusion. So the scope, we also have a scope for this E2/2 experiment. So the scope of this experiment is to study the theory in fluid mechanics that which covers the boundary layer concept and also determines the fluid flow when it comes in contact to an immersed body. So the main objective is to carry out experiment and to distribution and determine the distribution of velocity of the plate. So we can connect the fluid flow over immersed body to the real life findings, and we have tender some real life finding. So one of the real life finding is when an aeroplane moves through our atmosphere. So atmosphere is known as a flowing fluid. So it has its own velocity, and it's a flowing fluid, and when an aeroplane moves through a flowing fluid, it experiences a resultant force due to the interaction between the body and flowing fluid surrounding it. So in real life finding, it is same as the concept where a car moves in our atmosphere or on the road. So it tenders the same idea. So when an immersed body moves through the flowing fluid atmosphere, it experiences a resultant force. So this interaction which causes resultant force causes drag or lift. So this drag or lift is a factor which is necessary to cause the aeroplane to take off and fly. So without this the concept of flow over immersed body, this is impossible. So this is one of the contribution in our real life, and this is one of it. So there are many more. So my group mates will continue the presentation. Thank you.
My name is Muhammad Daniel bin Zulkifli. I will be presenting for the theory of fluid flow over immersed body. When a fluid flow past an object or the other way around, an interaction between the object and the fluid occurs. The interaction creates a layer that sticks on the object surface due to the viscosity of the fluid. The layer that created on the object surface is called boundary layer. Okay, this is the example of boundary layer that created on a rectangular plate. Characteristic of the boundary layer is influenced by the shape of the object, the speed of the flow or the object, and the viscosity of the fluid. As the boundary layer is stick on the object surface, it attains the same velocity as the object. As shown in the figure, the velocity changes from 0 to the free airflow velocity. So you can see from the picture, the velocity near the surface is almost 0 here, and here is 0. And far from the surface, the velocity is almost the same as a free stream airflow. This happens because the boundary layer is actually a molecules of the fluids that are disturbed during the collision that happens during the fluid past the object surface. The most collision happen is at the object surface, which is why the velocity of the object surface is zero. Okay. Next is the flow around the blunt body. As mentioned earlier, the flow pattern of the fluid flow that passes an object influenced by the shape of the object. When a fluid flows through a cylindrical object, a wake forms behind the object body due to the shear present in the boundary layer. So you can see here, there is a wake form behind the cylinder body and behind the airfoil body. The wake also present in the airfoil, but not as much as the cylindrical shape because of the shape, an object can affect the length of the wake behind it. Okay, next is theory of drag and lift force. The pattern appears due to the force that appears during the interaction between the object and the fluid. The forces that appears are drag force, lift force, shear stress and pressure stress. It can be split into two components. One acting on the same direction as the fluid flow is called drag, as we can see here is the same direction of the fluid flow, and one acting perpendicular to the direction of flow is called lift. So you can see here lift is perpendicular to the direction of fluid flow. The drag and lift force is a resultant of the pressure and shear stress acting on the body. Next is the drag force. Drag force is a resistant force caused by the motion of a body through a fluid such as water or air. The example of drag force in real life is stopping a boat from moving on the sea. As we know, on a boat there is no brake because boat does not need one due to the drag force. When a moving boat stops accelerating, it will be slowed down by the drag force until it's stationary. The drag force shall be calculated by this formula. Okay, next is lift force. Lift force is a upward acting force which helps an airplane to fly. As we can see from the figure, fluid flow around the top of the airfoil, which has the curve, is faster than the flat surface at the bottom. According to Bernoulli principle, faster moving fluid exert less pressure and slower moving fluid exert more pressure. So the pressure difference between the top curvy and the flat bottom generates an upward force at the flat bottom surface, which is here. There is upward force, and that's how airfoil shaped wings help an airplane to fly. The lift force shall be calculated by this formula.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Aiman Arif bin Majusuf. My number ID is MA19050. Today I'm gonna present to you about experiment 3, that is methodology. Okay, first we go to the apparatus for the experiment. There is we use 225.08 flow visualization apparatus, and then we use the HM225A flow bench. Next we go to the experiment setup. This is the machine that we use for the experiment, and then the other side, this is the component of the machine. We have the mobile rolling frame with the bench top. We have a radio fan, we have switchboard and drawer, we have the air intake pipe with throttle valve, thermometer, rectifier, removable nozzle effusion, funnel, off air pipe, picture and measure. And then we go to the procedure for our experiment 3. First we have the smoke generator needs a startup phase, so the airflow bench is turned on approximately 5 minutes earlier. And then number 2, the fan was turned on and the experiment was conducted with the minimal wind speed for better result. And then number 3, The remote trigger was actuated once or twice for practice and observation with drafted for data and additional findings were observed. The wind speed was improved and a further outcome was seen. And then number 4, we redo the same investigational procedure together with additional drag body, that is wing profile and orifice. And then lastly, we have the outline of the streamline illustrated on the flow on the sketch. Okay, that's all from me. Thank you.
Assalamualaikum. I am A19119 Muhammad Ikmal Haikal bin Rahim. So now I want to show you about our result and graph for our experiment. So this is the data we get for this experiment for fan speed H1 in millimeter for angle of attack 0 degree, 30 degree and 45 degree. So these are all data. Then I will show you our calculation for the experiment. So we use the initial head 137 millimeter. And how to calculate the delta H is delta H equal to initial head minus head H1. So we get the delta H 3.5 millimeter, and velocity we use the formula velocity equal to 2g delta H square root. So this velocity data. So after we use the formula, we get all the data for delta H and velocity. Next, after that, this is a CD 0.59, CL 0.84, and A for area we get 6.3 exponent negative 3 meter square, and density we use a 1.184 kilogram per meter cube. And this is lift off formula for drag force 1/2 density U square CD area, and this is a formula for lift force. The formula, the lift force formula same with the drag force, but CD we just switch to CL. And from the formula we get the drag force and lift force for each angle of attack for 0 degree, 30 degree and 45 degree. And this is the data we get from our calculation. So now I want to show you about our graph experiment. So this graph for drag and lift force versus fan speed. As you can see, this is a graph for angle of attack 0 degree. So the blue line is a drag force and the orange line is a lift force. So as you can see, when the fan speed increase, drag force and lift force will increase too. Next, for this angle of attack 30 degree, the graph same with the previous graph. When the fan speed increase, then the drag force and lift force also increase. And this the angle of attack 45 degree graph. So this graph same with the 30 degree and 0 degree angle of attack. So as you can see, the same thing happen to the drag and lift force. When the fan speed increase, the drag and lift force will be increased too. So that's all from me. Thank you.
Hello everyone, my name is Madhav Sarar Sivaram, metric ID FA19090. Today I would like to talk about the discussion part of our experiment 2, part 2, which is flow over immersed body. So let us look on the first question. Which body creates the most smooth streamlines? The body with the slimmest boundary layer will deliver the smoothest streamlines. This scenario happens because the roughness of the surface is proportionate to the thickness of the boundary layer, which has an influence on the streamlines of the surface bodies. Slimmer the boundary layer, the smoother on the surface, which leads to more straightforward streamlines observation. What does a smooth streamline portray? Laminar flow refers to smooth, routine airflows forms that happen around an object and signals a minimum interruption of the air initiated by the object's movement all through it. Streamlining is thus the contouring of an object's body in such a manner that its turbulent formation is reduced. A body with a slimmer body layer has a smoother surface, which results in direct, smooth streamlines than a body with the wider body layer. Besides that, a smooth streamline portrays the thickness of the body layer. The third question, what happens to the wing profile at 30-degree angle compared to the normal? When the angle of attack of a wing flying in the air reaches 30 degree, separation of flow occurs between the aerofoil surface and the wing streamlines. This appears because the adverse pressure gradients influence the shape of the body layer. The dropping pressure along the streamlines tends to urge the fluid along in the favorable pressure gradient, conquering several of viscosity's decelerating effects. Therefore, the fluid is unable to decelerate as much nearby the wall, causing a richer U-shaped velocity profile and sluggish growth of the boundary layer. Final question. What does a smooth streamline portray? Fluid streams from left to right through an orifice shape at a persistent volume flow rate. Despite the constrictor in the space in the core of the orifice shape, the fluid must be shifted at the same rate to retain this flow. As in effect, the fluid's velocity rises because it must flow quicker in the constricted area. A constant flow of feed can become constricted when forced through the spaces between the venturi tube. Because of this constriction, the fluid velocity grows at these points, resulting in a great moving fluid beneath the structures. Now let us look on the profile of the streamline. First of all, let us look on the cylindrical body. So basically, the flow will be like from inlet to outlet, but it will basically follow the shape of the cylindrical body. For the orifice, it's slightly a bit different because there is only one gap around at the middle, at center of course. So from inlet, it will flow normal and then it will focus on the center and then it will diverge when it comes out from the outlet. Now let us look on the wing profile. Same as for the cylindrical body, but for the wing profile, the inlet from the outlet will follow the shape of the wing profile. At the wing profile at 30 angle, since there is an angle of attack which is 30, so the streamline will follow exactly of the shape but at 30-degree angle of course. So let us look on the conclusion of this experiment. As overall, we could understand the fluid stream across the bodies, specifically on cylinder type. We clearly observe the behavior of flow when it passes through bodies. Flow division with angles and turbulence impacts are watched on the formation of the streamline. This testing was implemented to carry out an investigation on flow design of a symmetric aerofoil at various angles. The drag and dip forces have been calculated during the completion of this experiment, data findings and calculation as well. In addition, we accomplished the objective by identifying flow forms by plotting suitable streamlines over a cylinder model orifice and finally wing profile. So that's all from me. Thank you.